Dear friends, now we'll start the discussion of the first project for today. Sergey, Alexey, you're welcome.
Thank you.
Yeah. Okay. Thank you. Yeah, because we have very few participants, but we have some. That's really important. I would like to ask if we have two, in fact. One is Mr. Ebrahimyan, and another is Shahpuri. I apologize for my perhaps not correct pronunciation. Can anybody of you say something? I think you can turn on your microphone, or even show your face in the camera. Can you just say hello or something? Правильно я понимаю, что человек может включить свой микрофон, микрофоны не блокированы?
Да, все правильно.
Yeah. So, Mr. Muhammad, can you turn on your microphone? Yeah, actually, I feel pretty uncomfortable to talk to unknown persons. So, and even we have, I believe we have Muhammad only participating. Nevertheless, hey sir, okay, we have some chat from him. Hey sir, yes, okay. Can you, if you cannot speak, perhaps you can write. Can you write if you have read our problems? While you are writing, I hope I will explain a few things. So we have a list of problems devoted to what can be called definability theory. That's about defining some of the relations through other relations. For example, our main example was rational numbers, or shortly rationals, with an order relation on them. So we can define other relations such as between, it is ternary relations, a relation with three arguments, means x, say 1 is between x2 and x3. So that's an example of this relation. But other relations can be defined also through relation of order on rational numbers, and not easy task, but we found it very interesting, and few participants, or can say quite a few participants, solved this problem and found other relations, not between only, but also something which can be called cycle or link. Again, ternary relation and quaternary relation. So relations with 4 arguments, relations with 3 arguments. It has an interesting connection with group theory, transformation group theory, because you can distinguish between 2 relations having a transformation of, say, rationals or any other basic set universe with a transformation, keeping one of the relations invariant, and another, the second relation, moving, so being coming from being true to being false, etc. So then we considered a relation being the next or successor in nature in integer numbers or Z. So one binary relation, y equals x plus 1. And also we investigated what are other relations which can be defined through this successor relation and found infinite number of these relations, not equivalent to each other. And these infinite relations constitute 3 series of relations. The equivalence means 2 relations are equivalent if the first one can be defined through the second one. At the same time, the second one can be defined through the first one. So it can be, in the sense of definability, it's just the same. Yes, you can even formally define the closure operation as everything which can be defined through a set or collection of relations. So that's a line on which we moved over this few days, and we have many interesting ideas and discussions with the participants in the Tournament of Towns. And I hope you will join our discussions and try to solve the problems next days and perhaps months. So we will have an English translation of our second list of problems and send it to you or place on this, public space of Tournament of Towns, and you can try to solve them and return back to the first list of problems, which was translated into English. And I hope you found it interesting for you. So yeah, that's all I would like to say. And thank you, Mohammad, for joining us this morning. And see, hear, and read you again. Goodbye and good luck.